Have you ever thought of the color of the screws or the nails? If you look at them, they're different. And what is the reason for that? They are coated, but how do you coat a screw inside the frets? I would like to know that. So therefore, I have contacted Damian. Damian is owner of a plating company in South Africa, and he will tell about these coating technologies in this episode. So stay tuned, follow the entire episode and see how they coat it. And it's not only coating, it's tumbling. So see you. Hi, Damian.
Hi, Peter. How are you?
Fine. Welcome to the podcast, Everyday Metallurgy.
Thank you so much for having me. Yes.
Yeah, Damian, last week I was in the local shop buying some screws. I'm building a house for my hens. And
Nice.
then I looked at these screws and they were colored, they were coated. And then I looked, everything you buy there for the screws and nails and bolts, they are coated. So I said, if somebody has to learn about how coatings are on everyday things like bolts and screws, then it should be Everyday Metallurgy. So I looked for a top expert in coating, and then we met because you're not only one who knows about it. In fact, you do it as your everyday business.
Correct.
Yes. Can you give a short introduction to yourself, where you are in the world, and what you do?
Of course. Yes. Thank you for that flattery, calling me the expert. Got some shoes to fill. But yes, my name is Damian. I run an electroplating plant in South Africa. We have been in operation for over 50 years now. It's a family business that was started by my grandfather, and it's propagated through the generations. My father's been there for about 30 years now, and now I'm getting myself inside there, taking over the reins in certain instances, but still very much learning. My dad and my grandfather are like the real experts, and they are, they're very, very well known in the industry. It's a very small industry in South Africa. I've been getting to know some people. All the suppliers know all the electroplaters. It's quite its own little family, if you want to put it that way. Everyone, has like little backstories, and oh, we don't like him so much, and there's gossip in the air. So yeah, it's very cool. I've been there for about 6 years now. I can say that I've been there my whole life because when I was younger,
you grew up there.
Yeah, I grew up there. It was my backyard basically.
Yeah.
And I remember having a case of all the spare little pieces that just got lost along the way, and like I had a huge case of all these things. My dad would bring little pieces for me, and I'd like try and put stuff together. And so I've been very much involved ever since I was a small boy. And nowadays, I do take it very seriously. It's our family's livelihood. In South Africa, things are a little up and down, I suppose, as they are everywhere. And you just have to band together and do these things as a family. And I did work other places before. And I had to, come in and help out when COVID hit. Everything kind of crumbled and fell apart.
My dad, he said when I was about to finish my studies, do you want me to come home and help you in your business? And he said, hell no, you better find another place to make your rookie mistakes.
Yeah. And I was kind of told something similar because things were not going well. It wasn't time to take on new people. And it became an opportunity for me to start diving into different ways of electroplating and coatings just in general. We've started, when I say started, it's about 3 years now we've been doing a process. It's an alloy electroplating process, which I believe there's a few people in South Africa doing it, but there's really not a lot. And we've managed to really get this process down. It's the zinc-nickel alloy plating process. Yeah. And it's a superior plating to just plain zinc. Zinc will get you good results, especially with those different colors you mentioned. We call them passivations. Once you've plated something and you passivate it, you get different color coatings, conversion coatings, you get different protection ratings on those colors. So if you buy the silvery one inside your shop, it's not going to last as long in the same environment as one with the yellow or gold color. You even get things that look a little bit like olive drab green, and those are very, very strong conversion coatings, very strong passivations. And the silvery one is kind of like the run of the mill. And I wish we were at the factory now so I could actually like show you around and show you the machines and the work that we produced. But the run of the mill is the silvery one. The very common is yellow. I'm actually quite surprised that all the people are using yellow. It's used in construction. People use it for color coding in certain instances. It's not all about corrosion protection. And we have different grades of plating that we ourselves put. We have a trademarked process called Mega Zinc that is pure zinc, but we just plate it for an amount of time that the customer requests. And then we have different additives and different bath makeups that help the corrosion protection. There's other protections that people may need, like abrasion protection, scratch resistance, things like that. Some people want a matte finish. Some people want like a glossy, shiny finish. And that all plays into like this niche little market that we have of electroplating. There's different, there's so much to like sink your teeth into, and it's very difficult to actually start on one point and stay on that point, because you can really just go all over the place.
If we start with the content in the bath and the way you add it, because I remember when I went to university, we also made some coating, and we had components hanging in the bath, and then you coated it. But you do not hang a screw. How do you coat it, and how do you transfer the electric conductivity to it?
So that is that's kind of a two-part question, because you can do the hanging. And the hanging, we call it here, I don't know if the rest of the world calls it here, they probably do, but it's called jigging here in South Africa. At least that's what our little industry calls it. So jigging is when you take the piece and you hang it, and it's usually at a much lower voltage, which draws a lot less amperage, but the coating becomes quite uniform, and it layers on slowly but uniformly. And the jigging is mainly used for much bigger stuff. So at the moment, I'm doing pieces that are, about 600 millimeters long and about like 50 millimeters in diameter. And those have to be jigged. Where you hang inside the bath. So that's the one process. The other process, if you go onto, our website at Team, that's where we say we are the barrel electroplating experts. And barrel electroplating is when you take a plastic polypropylene barrel and you put it inside your solution, and you have either dangler arms, or some people have straight rods with rings hanging in order to make contact with the article that you're trying to plate. And inside the bath, there's two types of plating bars that we use. We use an acid zinc and we use an alkali zinc.
Mm.
The alkali zinc is our main run-of-the-mill stuff because it's a little bit cheaper to run, a little bit simpler to run as well. The only problem is it's got dangerous chemicals in like cyanide and caustic. So it's very dangerous to add stuff, and like, you got to kind of like have strict rules with PPE, or you're going to lose a hand, or an arm.
And you better keep it in
high
pH.
Yes. Oh yes, yeah. You do have to keep it at a high pH.
Yeah.
The additions of the chemicals do tend to naturally keep the pH quite high. More with the acid zinc, you'd have to start adding. You literally just dip it into the tank, but you add it into the solution and it will settle the pH. We use test strips to test the pH, or you can do titration methods for the zinc levels and stuff like that. But yeah, just coming back to the question of how does the barrel work? So our main barrels are a polypropylene hexagonal barrel. Kind of looks like a honeycomb if you look at it that way.
Yeah.
And inside the left and right of the barrel are these dangler arms. We have different ones. There's ones with flat plates. There's ones with just like probes like this. And we have ones that have got like brushes on them. And they just kind of like sit inside the barrel like that. All for different uses. The main one we use is the probe, the solid probe. And that makes contact with your rectifier. Now, the rectifier is going to supply a positive current, and it's going to supply negative current. And inside your barrel, you are going to have the arms becoming the cathode. And that arm rests on the work that this barrel now rotates inside solution with a gearbox, and it rotates like that, touching the work, making it charged. And the other end of the rectifier becomes, well, it has anodes sitting inside the solution.
But outside the trouble.
Exactly. Inside the solution there. Inside these, we use steel baskets, but we also use titanium baskets. Some of the solutions are a little bit more corrosive, and actually they tend to contaminate your bath chemistry. So what you have to use is like titanium in things like a nickel solution, or you can use normal mild steel, but it gets eaten away over time in the cyanide zinc. And it tends to be like a bit of a maintaining thing. You have to balance the metal with the zinc, and you can't have too much zinc. So inside your anode in the bath, you have your zinc pieces. We actually break zinc ingots and put them.
So they dissolve on the run.
Yes, they dissolve through with the current of the electricity and the makeup of the bath. It dissolves into the bath. In the cyanide zinc, the zinc will dissolve in, and the cyanide actually attaches to the zinc, and it becomes, my chemistry is not the best, but I believe it becomes it's called an iode, or some chemical term where it attaches to the cyanide. I'm no chemist. I'm purely an applier of metals.
That's fair.
So I don't know exactly what the name is, but you have your cyanide go, and it attaches to your zinc, and then through current, it will now attract itself from the anode, and it tracks through the solution onto the work. And with the barrel, why you have to have the barrel is because with all electroplating, you should have agitation. If you don't have agitation, you start running into finishing problems, not necessarily plating problems. The plating will come out, but the finish will be undesirable. I had problems today with the jigging, where I'm hanging these big pieces inside the bath, and I do have a pump that goes. But now with all this really cold weather that we've been having pumps freezing, pipes getting blocked, and like things, we need to like get that cleared. So the pump wasn't working properly. And I put these things in, and they're plating, they're pulling the amperage, everything's fine. And I take the piece out, and you can see that on the side you get all these burn marks. Well, they're not really burn marks, but they're like almost like gouges coming around this piece. And that's from the reaction taking place. It causes gases to develop around the piece.
Yeah, so
And
when,
as that gas comes up like this,
yeah,
it's actually blocking
yeah,
the things from being plated. So it looks like it's burning and it's dull. You get pieces that are, on the same piece, you'll get a section here where it's perfect, it's beautiful, it's shiny and everything's plated nice, but then you get like these streaks going up. And that's because I didn't have enough agitation. It's not blowing away those little bubbles that are causing so much issue.
And it could also be because the bath, if you don't have agitation, you will remove the metal ions. So you'll have a metal-free zone in the bath. And then when you don't have metals that can get rid of the current, then suddenly you start to break up the water.
Yes, there is actually a problem with using air as agitation through your bath, especially a cyanide zinc bath. Because as soon as you do that, the cyanide will actually separate from the zinc and you'll end up with a dead bath. And it's happened before. We actually use that process in our effluent. We have very strict water criteria in South Africa, and we get tested every month. And if you fail on any other test, you get heavily fined. So it's really something to take serious. And in that process, the effluent process, there is actually an air agitation process where it separates the cyanide from everything else, and all the metals settle down and becomes like quite a gunky sludge.
Yes.
And then, but then you're removing the cyanide and the zinc, and then the water can go through other pH stabilizers like lime, or in the case of what we do with the cyanide zinc, we don't use lime because that would increase the pH. We actually use the acidic runoff water from the passivations to neutralize the cyanide water. And post that, we use other methods to just get rid of all of those, the chromium and all the other particulate matter that's inside the water, all the toxins, and we get that out. And the water actually comes out pretty clean, but I wouldn't quite drink it then.
Okay.
I would let the water treaters,
do the rest.
Make the final handle, but it's good enough for us to put down the drain, and people will they'll be able to treat it much better than if it wasn't treated that way. But just coming back to our barrel, the reason it turns, that is the agitation. So as these pieces are turning and tumbling inside the barrel, it's knocking off all those bubbles, and it's knocking out any stuck air, because air can get stuck in some cavities, and it knocks that all out, and it forms to quite a uniform coating. I hope I'm not rambling. You must just let me know if I'm going off on a tangent, and I'll try and bring myself back.
Just go.
When I talk about it, it gets like I said, it can go either way. It really can. But so the jigging is a new section that I've started, the hanging of the pieces. And it's going quite well, except today I had a little bit of issues, but I do understand where to fix that. And with the barrel, that's something that we've been doing for very, very, very long. And my grandfather, like I said, he was the one that began this process, and my dad continued in his footsteps. And now we're very lucky to still be going after 50 years, and after all the, I'm sure you might hear some news over there about the state of South Africa and how things, are on a little bit of a shaky ground. I don't want to get too political, but it is a bit shaky. And in spite of all of that, we've managed to hold our own, and still we only produce top quality plating. There's a lot of platers out there, and we need to distinguish ourselves from everyone else by being honestly one of the best barrel electroplaters in the country. We are having a lot of success in the coastal areas. We do have a lot of success up here in the Highveld, which is a lot drier, but there's a lot of people that go on safaris and a lot of people that go, they have pieces for their boat that goes on a lake, or there's a lot going on up here as well that need a good coating to protect their work from.
Damian,
but yeah,
when you make this coating, when you put power on it, you talked about, are we talking something like 4 to 5 volt and then 2000 amps, or what level are we at?
Not quite 2000 amps. I'd be very scared to be an electroplater if that was the case. But it is quite high. However, it's DC current, so it's not too dangerous. You won't really, there is some danger. Don't get me wrong. But what we're working with jigging is around 2 to about 5 volts. It will all depend on the size of the article. Generally, a rule of thumb is the larger the article, the more voltage you're going to need, the more amperage it's going to pull. The surface area is much larger. But where the real amperage is getting pulled is inside the barrels, because you have thousands of little pieces with a big surface. If you add it all together, the surface area is quite huge. And we're pulling anywhere from about 400 to 600 amps on the barrels. And it's heavy loads. We pay a lot of electricity. So
I could imagine. And then what is the time and temperature in these baths? Are any of them heated, or are they running at ambient temperatures? And then how long time does it take to coat a screw or a bolt like that?
Good questions, because there is no real one answer. And I could tell you the one answer, but you're going to try and do like different articles and they're going to come out badly, or they're not going to work, or they're going to peel, they're going to bubble. That's another problem. But like, a rule of thumb is to just, put it in and see. And to try and plate it for at least 30 minutes, just so that you could get something that you can see if it needs more time, or if it needed less time. Generally, a rule of thumb is, I'd say, about 45 minutes. Cyanide zinc, it likes to be at around 28 degrees. Acid zinc can run a little cooler. But it all depends on the articles. It all depends on if there's tolerance boundaries. If you're talking about a set screw, if you just plate the thing for 3 hours, you're going to try and put it into a standard nut, and it's going to be overplated. And you're not going to be able to use the piece. So it's very shiny, and it'll come out very shiny, very nice. But
what is typical thickness of the layer?
So that again will depend, but typically it's around 5 to 10 microns of plated matter onto the article. If you're plating with the same voltage and you put in a very small screw next to a barrel that has bigger screws and the same voltage, typically the smaller screws are going to have a lot less plating. It needs to kind of be shared among all these little things. So when that happens, you need to put either your voltage up, or you need to put your time up, or you can make an addition to your tank that will make the efficiency go up. There's a few different things, but usually the easiest way is to literally just put the voltage up and not too far up. You don't want to blow up your whole tank, but if you're starting at about 10, you might want to go to 12, and with smaller items you can get away with that kind of stuff. So it's a very trial and error kind of game. And one guy will come with a job that's constant, and you learn that job. And your tanks, you have specific tanks just for that job, with the time, with the temperatures. With the zinc, the temperature, it does play a massive role. When we have very cold days like today, the plating doesn't want to take, and you have to warm the tanks up first
Yeah.
before you can confidently say that you're plating correctly.
Mm.
But where it really plays a role is the alloy plating that I mentioned earlier with the zinc-nickel. And in your precious metals, kind of like your coppers and your nickel and your brasses and things like that, you really need to get your temperatures right. Otherwise, the plating just won't work. It peels and it just it flakes off afterwards. You can run into some serious problems with the more delicate sides.
Yeah.
But yeah, typically that's around the microns, 5 to 10. And you know, we have customers that request more, and we can do more. Yeah, we do try and get a consistent layer every time that we do some plating.
Yeah.
So yeah, I would call that about typical. Yeah,
Yeah.
as typical as it can be. Yeah.
Yeah. You have been talking a lot about zinc, different kind of zinc coatings. But I also remember chromium coatings
Yes.
has been a big issue, and I have previously been talking to a professor from the Danish university about a candidate to substitute the chromium 6
Yes.
hexavalent coating.
Yes.
Are you dealing with that, or are you dealing with chromat coatings?
So our local industry is quite, I don't know how to phrase it, but quite cowboyish. We like we like danger over here. So we still plating things like cadmium, which is not RoHS compliant, very poisonous. And we do plate with hexavalent passivations. But we do have a process that is trivalent, which is what everyone is trying to move towards, because the chromium inside the hexavalent passivations is very dangerous. It's very toxic.
Yes.
Look, I'm not going to go and drink the C3 passivation either. I mean, that's also very dangerous, but it's just much easier to treat. So when it goes down your drain and the water guys have to treat it, it's a lot easier for them to treat the Chrome 3. And with the new technologies, it actually performs a lot better than the traditional hexavalent chrome. So it's the one that we use, at least on the zinc, it does perform much better than our hexavalent chromiums. I think the yellow and the one we use as the trivalent is pretty much on par. They give around the same salt spray hours in a cabinet if you had to put them together.
Yeah.
So yeah, we do use that, and we have a lot of customers asking for the chrome free, the C3 trivalent, hexavalent free. There's 2,000 names for the same thing, but we have a lot of customers asking for that because it does go overseas, and some guys have very specialized pieces that are being sent overseas, and they can only use C3 passivations. So it is a very prevalent issue that we deal with. We're actually looking now at trying to get a yellow that is also hexavalent free, because we kind of got like a white. We got the clear passivation, which is chrome free, but now we want to move on to the yellow and maybe even the other colors as well. But we do that.
Yeah, but the Chromium 6, when you do that, it's both for to be beautiful to look at, the silvery polishing coating, but it's also for wear because it's very hot. Is it the same with the Chromium free? Can you do both corrosion and wear and the beautiness?
Yes. A lot of our customers that use the Chrome 3 is, when they're using hydraulic fittings, and it's not necessarily too many items that need abrasion resistance. And I do know that with this new technology that we're currently using, the lattice structure is very tightly bound, which does make it a little bit brittle. So if you had to throw it onto something with high force,
Yeah.
it can crack. And it's strong, but it is brittle, so it does crack. I know that our the Chrome 6 is very brittle as well, but I've bent a piece that I plated and made it the clear passivation with the Chrome 6, and it takes some time for it to actually like start like cracking, and the zinc underneath is actually what cracks first. But yeah, I can't say for sure if the Chrome 3 is better than the hexavalent, but I haven't actually gotten to that point where I've had to test it or I've had a customer complain about it. But I do believe with the lattice structure being so tight that it is a bit brittle. So it does have, some cons. I think if you were going to put it on pieces that you would usually have normal C6, and people were finding, oh, the abrasion is quite nice, it's protective. And then they moved to a Chrome 3 and they could find that, oh, maybe it's not so protective. I can foresee that probably happening. Yeah. A passivation is also it's very thin. It's 0.005 microns sometimes. So that can just be, if you rub it enough with your hands, the oils on your hands are going to wipe it away. Yeah. So it's a very thin layer. But I would say with all of the zinc passivations, the scratch resistance and wear resistance, abrasion resistance is quite low. Once you start moving on to the alloys and the alloy passivations, the abrasion resistance becomes a lot higher. So yeah, that is a problem that some customers would run into. Like it does scratch off quite easily.
Now we have been talking about bolts and screws and that.
It's my life.
Yeah, but I'm also working with magnets. And
okay.
Cool. Neodymium iron boron, and they are also coated, and typically they are nickel copper nickel coated.
Yes.
So first you add
strike.
Yeah, you put a chemical layer of nickel.
Yes.
Not electrically, but it just chemical deposit.
Yeah.
And then you coat it with copper, and then you coat it with nickel.
Yes.
Are you also doing that?
So there's two processes in the beginning of that stage that we are looking at doing, but we just haven't gotten around to it. And I've done it once before. There's an electroless nickel process where you'll literally just put that inside the nickel, and I don't know, you heat it up as well. And after about like half an hour or so, it actually just like literally just magnetizes itself onto the article. Yeah, that's the electroless nickel. That literally like magic. It's quite crazy.
Yeah. I think we call it chemical nickel.
Okay. I actually have had guys say chemical nickel and the electroless nickel, chemical nickel.
Yeah.
I think that might be one in the same. The other nickel, it's not necessarily a coating, but it's called a nickel strike, where that does involve electrical current. But it does give that, it basically just flashes on a nickel ready to receive other platings like the copper. And then after that, the copper is very readily to receive the on top nickel. That is interesting. I don't know anything about plating onto magnets. I don't have customers that do that, but that is very interesting, and it's something that I will look into. How to plate that. But we do a process where you can put the nickel strike, and you can put the electroless nickel or the chemical nickel, and then we put it into our cyanide copper tanks as well, which actually forms a layer. You get the cyanide copper and you get the acid copper. The acid copper is very uniform. It's shiny. And copper readily accepts pretty much anything. It's a very, very versatile plating to use if you want to use something else. Like you have to do copper nickel instead of just nickel, because then
Yeah.
it doesn't adhere properly.
Yeah.
With the finish of the cyanide copper, it's a lot more matte finished, and there's micro pits inside there, and it kind of becomes sticky for the next metal to stick on
Okay.
there.
So you on purpose you make micro pits.
Yes, yeah, you make it like slightly abrasive, just so that the next layer can really have something to grab onto.
Yeah.
And nickel likes that. Nickel likes copper, and then to be plated onto that. So yeah, those processes are very important. With the magnets there, I thought you might have said that there was chrome on top of the magnet. I don't know if people do that, but
I don't think I haven't seen that.
yeah, because a common practice is to do copper and then nickel and then chrome, and that gives a very, very hard finish. And you know, those old school 80s cars bumpers and all those finishes on those cars, like all that chrome was copper and nickel and chrome and then polished afterwards, and to give that kind of finish. And that's why those things are still rolling around on the road, because I mean that stuff lasts forever. Chrome is really, really hard. Yeah.
But what other segments are you coating for? When we you talked about these big ones, but what kind of business is that?
So there are like the industries. There are quite a lot that we are involved in. When I say involved in, we're pretty much just the middleman. But it's pretty much everywhere. It's electronics, it's construction, it's automotive, it's decorative. There's guys in the mines. There's guys just retail. You know, some guys buy from someone and then they don't like the plating, or they want to change the color, and then it's just a resale thing. So there's plenty industries. I think our main industry in South Africa is the construction and I'd say the mining and construction industries. Those are pretty much the guys that are always coming and always filling up our barrels.
Yeah.
Yeah.
You also have a quite big mining industry, and going back to the magnets, there's also a mine digging rare earth materials in South Africa, and with these political situations we have today with China and US in the battle, there might be an opening for other countries to deliver magnet materials.
Yeah, and I do know that our mining sector is going through its own waves at the moment, but there's definitely a lot of opportunity, and there's a lot that we can still offer in this country in way of raw materials.
If we look a little ahead, you talked about that you had developed the alloy coating with zinc-nickel. What is coming up? What will be next in the world of electroplating? Is that next, or is it even more complex with introducing compound materials? I've heard of people that coat nickel and include small Teflon particles in it. To make it very slippery.
Right. Okay. I haven't heard of that particular coating. It's a learning experience every day. I read a lot of magazines from overseas for coatings, and it's such a vast wealth of knowledge that exists out there on these things, and people are trying crazy things with coatings. It's very fascinating. So in our case with the zinc nickel, I would say that's probably the most finicky. I wouldn't say it's too complex, but it is very finicky. It's very hands-on. If you leave it for an hour or two, you're going to come back and it's going to be completely different. Your bath makeup changes very, very quickly. And it's very tight tolerances. If you're not keeping your tank inside those tolerances, you do tend to run into issues that you have to either start again, or post-plating, you have to make up for it in other additions. But the zinc-nickel...
What happens? Does it only coat nickel or only coat zinc if you get out of balance?
It can happen that way. It won't only exclusively coat one metal. There's different ways of doing the zinc-nickel coating. There's a method that uses 2 rectifiers at different voltages. And there's a method that we use that has 1 rectifier and replenishment that needs to happen inside the tank. The way that the ions are drawn out of the solution is just very rapid compared to the zinc side. That's in my experience. That's what I've experienced. That it's very quick to change the bath. Now, obviously, as soon as your volume of the bath increases, that tends to tone down a little bit. If you're using a very small, like a testing solution, if you use a cell test, I mean, you can plate like 3 pieces in there and your whole solution will be depleted. But if you use what I'm using, like 10,000 liter tanks, it's very slow to draw out, but it's also very slow to replenish. So we have to balance it, and we have to do regular tests, regular analysis of the samples, go to the XRF machines, do our own titration methods, and you have to constantly do it. Otherwise, the tank, it can just bomb out. It can come to a point where the ratios will just be on the cusp of coming out. Be it with temperature, which it plates out nickel quicker, or it's plating out the zinc-nickel, the zinc quicker, and then your ratio can dip, and then all of a sudden you've got a part that is just, it's got way too much nickel in it, or it's got way too much zinc in it, and then your passivations aren't sticking, and all the passivations are just wiping off or burning. There's instances that I've had where the part will come out and it's black out of the tank, and everyone's scratching their head and going like, oh no, what's going on? But it's a very finicky process. It's an art. You kind of have to treat your tank with the tender hands. As my grandfather says, like, if you look after the tanks, they'll look after you. So we try and do that as best as we can.
What is the purpose of the alloy coating? Why do that instead of going clean nickel or clean zinc?
So I'm sure you and the viewers might be aware of the galvanic table, where we have the different potential differences between metals. Specifically with zinc nickel, I can't talk about the other metals too much. But specifically with mild steel and zinc nickel, that galvanic difference becomes a lot closer to 0. So the potential difference in itself as the coating is very, very low. And when you put that part onto a ship, or you put it onto a car, or you put it where there's heavy corrosion that can take place, it doesn't sacrifice, the layer doesn't sacrifice itself as quickly. It really makes it quite difficult to actually corrode. It's like taking a piece of zinc slab and just like hanging it in the air somewhere. It's going to stay there forever. If you take your everyday keys that you use to open and unlock your doors, those are just straight zinc cast keys, and they will never rust. It's just a piece of zinc. So that's kind of the idea that they're trying to do with the alloys. They're trying to bring this galvanic difference to the center so that it doesn't sacrifice itself as readily. With normal zinc coatings, that is what is happening. The mild steel has a potential difference between the zinc, and it will slowly chop away at the zinc, and the zinc will give
Yeah.
itself off in a white rust first, and then it will go to
Yeah,
red.
and on some big ships, you put sacrificial anodes in
Mhm.
off sync
Yes.
exactly for that.
Yes, that's something I've been reading up on, and it's very,
Mm.
very interesting how they actually like kind of like ground the hull with
Yeah.
electrical current so that it
Hmm.
doesn't corrode. It's
Yeah.
very interesting.
Mm.
So yeah, we try to do the alloy in that way in terms of just getting a much better corrosion protection,
Yeah.
especially for the automotive, the aerospace, and the marine
Mm.
environments.
Yeah.
We try and do that.
Yeah. Damian, I have a last question before I'll let you go.
Is it
We
over
talk a lot.
already? Oh no.
Yeah, yeah. We talk a lot about recycling and design for reproducibility or design for reuse. But when you mix materials and when you coat materials, then you get a lot of iron, but you also get a lot of zinc mixed in it.
Yes.
Uh, are there any thoughts in the galvanic industry on recyclability?
To be honest, I don't think so. Not in South Africa.
Mm.
People are very much like, let's go, let's go, let's go, let's work, let's just get it out, pump it out, as quick
Yeah.
as possible.
Mm.
The recycling, as far as I know, is not a major concern
Mm.
for people in the industry. The only thing I really know anything about recycling of is the water that we use.
Yeah.
So that's like the extent that I would know. But I wouldn't say that I hear a lot of people concerned about that. In the
Mm.
industry, like I say, like people just want to get it out, get it going. People are trying to maintain businesses by, constantly bringing in raw
Mm.
and
Yeah.
processing that raw. And
Mm.
now to bring in like a recycling element to that is very expensive.
Hmm.
So they usually outsource that to people that do have that, but I don't hear of it it's not a very common thing that I hear of.
Mm.
And you do mean when you're extracting, like if you have a cell phone and you're
Yes.
extracting like that. All
Yeah,
right.
you harvest
The harvest, yes,
what was
like
in
the
it.
gold and like the raw
Yeah.
materials. But that I
And
do know there are. Sorry.
yeah,
There are people that do that, but like I say, it's like their own industry actually, and
mm.
usually guys like us would just, or people that's supplying us the raw materials, we're
Mm.
just trying to maintain and trying to supply. So it's not a huge thing, but
Mm.
it definitely does happen. Yeah.
Yeah. Yeah, it could be like in copper. Copper
Mhm.
cables are quite high in purity,
Yeah.
99.9, to have a high conductivity.
Yes.
And you also need high purity copper. So maybe you could purchase stripped cables and use
Yeah.
that as raw material in your copper bath.
Well, now that's how we keep our shop going with all of our old cables, and we clean those. And so I guess we recycle ourselves, and
Yeah.
yeah, we also
Mhm.
do that. And
Yeah.
we keep pieces, and the copper cable, some of it like gets really corroded and it has
Hmm.
green corrosion.
Yeah.
And then we clean that off with a special solution. And
Hmm.
once we've rinsed that off, it's pure copper. It's
Yeah.
perfect copper. And then we use that to plate. And
Mm.
yeah, no issues there. So we do some recycling. Yeah.
Yeah. Yeah.
Yeah.
You can put that on the homepage. We are
Yeah.
recycling.
Yeah.
Yeah.
I care
Yeah.
about the earth. Yeah, we do a lot. We do a lot with the water to look
Mm.
after, the environment.
Yeah.
It's not, I can't speak for all the electroplaters out there, but for us, it is very important
Yeah.
to
Mm.
maintain the healthy environment. Yeah.
Mhm. Yeah. Um, I have one more question before
Okay.
we have to stop, because you inspired me when you said I am reading a lot to learn. So would you help our listeners also to be able to find more information by sharing what are you reading? Where do you find your information?
Of course, I can do that. I'm gonna push myself a little bit over here and say that I actually have a blog that I've started on the website.
Mm-hmm.
There's not a lot. It's one blog at the moment. So don't expect, like huge things from there. But there's a few articles that I get in my email pretty much every day.
Mm-hmm.
And there's magazines that still come out. One is in America, and it's called Product Finishings, I believe. That's something that I read a lot. And there was one it's called the Corrosion Bible or something or other like that. And there's that's like today what you would find on in magazines and things like that. But there's also like traditional readings that you could, if you could get your hands on it, I would highly recommend. It's very boring, but read through all the ISO specs. When I say all of them, like if you want to do a particular coating, read through all the ISO specs. It can teach you a lot. Read all the testings from the ISO, also the ASTMs, and I forget the British one, BS something or other. But there's those standards that I read a lot. I read a lot of the standards, the ISO standards, the ASTM standards, and the British one, BS something or other. And if you can get yourself a copy of the Canning's Handbook, I think we're on edition 30 or something right now. But the Canning's Handbook is the Bible for electroplating. So if you ever want to learn anything about electroplating, the Canning's Handbook is the one. And I mean, like, there's a lot of suppliers of chemicals and a lot of suppliers of raw materials and stuff that will give you a lot of information. I'm on good terms with a lot of our suppliers, and they help us out all the time. So they'll give me resources. But casual reading, I'll stick to the magazines. Yeah, Product Finishes from America. I think that's a good one to start out with. Yeah,
wonderful. We can share links to these magazines and homepages in the notes below the YouTube episode.
Perfect. 100%. I'll send those to you. Yes, and then we can give them to the viewers, and they can do their research, do their homework, as they say.
Yes, exactly. Yeah. There's homework after watching an episode here.
Yes, yeah. I'm sorry if I ramble a lot, but it's good to talk about it. There's a lot of information. And to educate people on this kind of thing, I'm starting to feel is quite important. It's in every industry. Every industry, the electroplating can be found. And no matter how small the components are, or, they electrogalvanize huge construction pieces, by hot dip galvanizing or submersion coatings. There's a lot of things that can be spoken about, and it's just a very, very big industry. So it's good to feel like I'm bestowing some knowledge, and I hope someone had learned something from this. And it's a pleasure. And thank you for having me.
The pleasure is on my side. Thank you very much for sharing.
Thank you so much.
I'll let you know if questions come up.
Perfect. I'd love to. Yes, I would love to hear the questions.
Yeah. See you.
I'll see you. Thank you.
Yeah, bye.